Yeah, here's a velocity versus time graph. And I feel like these are the simplest ones really to interpret, right? We've got positive velocity. We can go to the right. This means I'm going to the right. And below 0, this is negative velocity. This just means I'm going to the left. Or this could be forward if we're in a car. This could be backward. Backward. Why did I start backward with a W? Backward. Backward. Okay. Forward, backward. So let me just give an example, right? I start off and my velocity is 0 for some period of time, right? I'm waiting to get out of the parking lot. And suddenly I see a break in the traffic, so I speed up. But I don't want to go too fast. So when I reach 20 miles an hour, maybe a little faster, I go that speed. But then I get to the end of the speed zone, and I speed up to... Right, so the slanty lines, that's accelerations. This is constant speed, right? Okay. I speed up to some constant speed, and then it's like, oh, the light change. I slow down and stop. But then I realize I'm in the crosswalk, and there's the people giving me the stink eye because I went too far, right? So I back up, I wait a little bit, and then I back up a little bit, and then I wait, and then the light changes, and off I go. Anyway, that's what we spend a lot of time looking at speedometers, right? So I feel like people are more intuitive about velocity graphs than they are about position graphs. So let's look at some and let's just interpret it, right? Okay, we want to know in general which way we're going, what's happening to the velocity, and is there a positive or negative acceleration? So let's look at some of these, right? Okay, so notice that we're going forward or we're going to the right. This is all positive velocity. Notice it doesn't change. So the slope is 0. So therefore the acceleration is 0, right? I'm just going at a constant speed. It doesn't change. At 1 second, at 2, at 3, at 4, at 5, it's always the same speed. It just doesn't change. And I'm moving in the positive direction. In the positive direction. All right. This is like me driving with the cruise control, going east. The drivers on the other side of the road were doing this. They were, I guess, going west, right? So this is just we're going to the left. We know that because it's in the negative region, right? If to the right is positive, then left is negative. This is a constant negative velocity, right? The acceleration is still 0, right? Because there's no slope, right? It doesn't change. So let's look at some that change. Aha, there we go. Look. All right. So now here we've got all of these, by the way, are positive velocities, but we start off and we increase velocity for the first couple seconds, right? So that's an acceleration. And that's a positive acceleration because it's a positive slope, right? Okay, then this is a constant velocity. Constant positive velocity, right? This is another acceleration. This is a more abrupt acceleration, right? See, it's steeper than that one, right? It goes up by whatever that unit is, and it does it in half the time, right? Or less than half the time, right? And then more positive constant velocity. Okay, and then there we go, right? So this could be, again, me pulling out of the parking lot. I go to 20 miles per hour because I don't want to get a ticket. As soon as I get out of the school zone, I speed up to 30 or something like that, okay? Only it's 35 miles an hour, but anyway. All right, let's look at the next one here. Ooh, okay. So this is literally, I once drove a car that had cruise control, and you could hit resume on it, and it would just take you from 0 all the way up to whatever speed it was, right? So I was so lazy. I paid the toll in like Ohio. I pressed resume and my car went, and then at some point it stopped accelerating, right? And by the way, at this point there's jerk. When the acceleration changes, physicists call that jerk. We're not going to get into that, but it's the rate at which acceleration changes. You might notice this. When I was a kid, we used to have mopeds. And the mopeds were designed to only go 30 miles per hour. Now, they were limited because they had a little device in there called a governor, and it just sat there and looked at the engine or the wheel speed. And when the wheel speed reached 30 miles per hour, it would let off the gas. You couldn't control it. You couldn't go faster. Okay. Now, I know kids that disabled the governor. You know, the moped could not safely, but a moped could go 40, 50 miles an hour, right? And so when you start off, right, you go down 2nd Avenue in Cedar Rapids, Iowa, right, you just floor it, right, and the throttle of the bike would go boom. And when you reach that, whatever that speed was, I think it was 30, you could feel the acceleration stop. It just kicked out just like that. And you'd go 30. You couldn't, you could do anything you wanted with the throttle, but it just wouldn't go faster than 30. So that's me. This is positive acceleration. Right, this, by the way, is these are all positive velocities, so we're moving to the right. Here we're going to the right faster and faster. And here we go. This is a constant velocity, right? So the acceleration is 0 here. Here it's some positive slope, right? Okay, so slopes of these things are accelerations. All right, let's look at another one. This is, okay, so this is at the end of Ohio. This is what I did. I played this game where I turned off the cruise control. And I tried to guess how far before the toll booth, right, in Ohio, that I had to turn it off so that it would stop right at the toll booth. I missed by like 10 feet. People started honking behind me. I was like, come on, be patient with my game here. Right, so this is, I'm slowing down. So this is a negative acceleration for this part, right? And then here I'm at rest. The velocity is 0. I'm not moving to the right or the left. So basically I'm coasting to a stop. Or I could be using my brakes. I'm just going from some positive velocity to 0, right? Positive velocity to 0. And you know that if you have a positive velocity and you slow down, it has to be a negative acceleration, just from first principle, right? If they're in opposite directions, you're slowing down. All right, let's look at another one. Ooh, this is kind of fun. This is stop and go traffic, right? So I speed up for 1, 2, 3, 4, 5 seconds maybe, right? This is all qualitative, right? I speed up for 5 seconds, 1, 2, 3, 4, then I slow down in 4 seconds, right? So this is positive acceleration. This is negative acceleration. But all of these, by the way, all of these velocities are positive. I just speed up, I slow down, right? Now, the question is, what would a position graph look like of that? Of me speeding up and slowing down? Well, it's subtle, right? Let me just show you what it looks like. This is what it would look like, right? From here to here, I'm speeding up. Notice that the slope, remember this is a position graph, right? Okay, the slope is getting more and more and more and more, and then the slope gets less and less and less and less. Starts off at 0, ends at 0. Convince yourself that these are the same graph, kind of. I mean, I'm not sure the exact shape, right? But it's the same thing, right? Speed up for 5 seconds, slow down for 4. Speed up for 5, slow down for 4. All right, try the whiteboard problems.